Hi guys, we are on the last lesson for chapter 1. So after this lesson, we'll be getting ready for our test. We are looking at chapter 1, lesson 6 today. So make sure you have those notes out. What we are looking at today are basically just a general pattern that we see on a graph. And so the last few classes we were looking at graphing points and turning a word problem into an equation and then graphing the input and output of an equation onto a graph. And today we're going to look at how do we notice or see patterns on our graph. So sometimes when you graph points, or you get a set of data, a set of information that you want to turn into a picture. So maybe you get a set of information about the cost of how much a car costs over a year, like the average cost of a car. And you start to see it's not going up consistently, but you see as over time, cars cost more money, maybe because there's more features on it, or they become more innovative and the price of a car goes up. But it doesn't go up consistently where it just makes a straight line. We start to see a pattern. So we can show these patterns through a scatter plot. So here are scatter plots, and you probably have already noticed a picture of scatter plots down here. And we're going to talk about each relationship of a scatter plot. So if we see our plots going up generally, as x goes up, y also goes up. So remember, this is our x-axis, and this is our y-axis over here vertically. And as x gets bigger and bigger, y goes bigger and bigger, gets larger, and it's going up towards the right. We call this a positive relationship. So don't mind this here. It's just a picture I found. So we can call this a positive relationship. And as you're looking to the right here, you probably can already tell what it's going to be as it goes down. If y goes down and x goes down, that would be a negative relationship. And then if there's just plots scattered throughout and there's no pattern whatsoever, this would be no relationship. So no relationship. And correlation is another word we can use for, relationship, like is there any connection? But in this class, we'll refer to it more as relation, okay? So let's look at an example. Determine whether a scatter plot of shoe size, sorry, there's a typo, shoe size and height of people at a gym might show a positive, negative, or no relationship. Explain your answer. So as we look at this, we measure, maybe as people walk into the gym, we measure everyone's shoe size, and also we measure their height. So we look at the connection between how big their feet are and how tall they are. And so immediately when you see this, you see as the shoe size gets bigger, the height also gets bigger. So height affects shoe size. A person's shoe size increases as their height increases. Therefore, a scatter plot of the data would show a positive relationship. So this has a positive relationship. So let's read through some examples, and we can decide as one goes up, will the other one also go up? And that would show whether it's positive, negative, or maybe there's no connection at all. So number 1, fat grams and the amount of calories in food. So as you have a fattier food or something that has more fat in it, do you think there would be more calories? Some of you might not know, but yes, there would be. So as fat grams in food goes up, the calories go up. So this would be a positive, as both would go up, right? Positive relationship. Okay. Number 2, time spent relaxing and blood pressure levels. So as you relax, will your blood pressure increase or decrease? So think of, you can measure your heart rate to show blood pressure. So if you, let's say that you had been active and then you spent some time relaxing, would your blood pressure go down? I think so. So as time increases, the blood pressure goes down. So this would be negative. It's a negative relationship. Number 3, age of child and a number of siblings. So let's think about, even in our class, if you think about your classmates, as people have gotten older, have they like had more or less siblings? Hopefully not less. That would be depressing, right? So not necessarily. Just because you're older doesn't mean you get more siblings. Like if I was, you know, 100 years old, and that doesn't mean I increase in having siblings, right? So I don't think there's any relationship here. No relationship. Because whether your parents want to have more kids or not is not dependent on your age, believe it or not. Maybe a little bit. No relationship. You can ask your parents that, maybe. That's a question for them. Number 4, age of a tree and its height. So as time goes on, will the tree grow taller? Will it stay the same? Well, hopefully a tree will grow, right? So that would be, as the time goes up, the height goes up. So both go up means it's positive. Positive, I think. Can't really see that very well. All right, so why don't you guys pause the video and see if you guys can determine what relationship these are. I'm gonna pause as well, and I'll work these out, and then in a second, you'll see them all played out. Okay, so let's take a look here. How did you guys do? You can check your answers. So number 1, a person's jogging speed and the time spent jogging. Oh, I think as time goes on, your jogging speed might go down, right? Because you get tired. So the longer you jog, the slower you maybe will become. So that would be negative. Hopefully it's not. Maybe it stays consistent. But normally, the longer you jog, the more tired you are, and then your speed goes down. Number 2, the size of a family and the weekly grocery bill. So think about, if you have more people in your family, don't you have more mouths to feed and you have to buy more food? So your grocery bill is going to go up. Number 3, the size of a car and the cost. Okay, I don't think the size necessarily equals how much the car would cost. Usually it's related to other things, not so much the size. And so there's no relationship there. Number 4, a person's weight and percent body fat. So as your weight is higher, usually it tends to mean that you have more percent body fat. It could be to other reasons. Maybe someone's tall and so they have a higher weight, but they are still lean. So some of it does base off of circumstance, but generally speaking, it's positive. Number 5, time spent playing video games and time spent on outdoor activities. So if you spend more time playing video games, you have less time to go outside. There's only so much time in the day. So if you use the time that you have in one day, spend it more on video games, then the remaining time you have less to go outside. So as time with video games goes up, time spent outdoors goes down. So that would be a negative. Okay, number 6 says, draw a scatter plot with 10 ordered pairs that show a negative relationship. So honestly, this is not asking you to do anything too crazy. You're just creating a scatter plot that shows a negative relationship. So yours can look different than mine, but you need to have 10 points on here. So I have 4 so far. And you just have to show that there's a general relationship of going down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so look at my plot. It just shows a general relationship of my plot going down. All right, our last one. Now, this is bringing everything together. We're going to plot some points. We're going to figure out how to label our graph. And we're also going to make a title. So for this exercise, it says, use the table below which shows the federal minimum wage rates from 1950 to 2000. So basically, these are the minimum wage rates starting from 2050 or 1950 to 2000. So basically, how much someone would earn an hour in these years for the minimum wage. So the first thing that you need to do is make a title. Every graph needs a title because every graph describes something, a relationship between two things. And so this talks about federal minimum wage rates. So we could, just use this as the title, but that's pretty long, right? So I might just write minimum wage here. As my title. So when someone sees this graph, they immediately know that this graph is about minimum wage. And then we have to decide, well, what's going to go on my X and what's going to go on my Y? What goes on your X value is usually the measurement that doesn't change. Like it is usually related to time or the thing, really, it's like the thing that's going consistently up, okay? So we're gonna label our x-axis the years. So when we see the numbers, we know that it's related to years. Then our y-axis is going to be the cost, the minimum wage. So I might put a dollar sign right here to show that this is related to money. And then now we have to decide, okay, how are we going to space out our graph so that we can fit all this information on there? Now, up until this point, we've been counting up from 0, 0 here to like 1, going up by ones. Well, if we go up by ones here on years, we're going to put a lot of tallies until we get to 1,950, right? 1950. That'd be a lot of tallies. So we can actually think through, well, I'm just going to start with maybe 1950, and then I'm going to think through, how should I space out my graph so that it evenly spaces out until 2000? Now, one thing that's important is you want to go up evenly. You don't want to go 1951, 1952, and then all of a sudden jump to 1960. Your graph is not going to be able to show accuracy if it's not going up consistently. So if you're going up by 2, every box has to go up by 2. If you go up by 10, every box has to go up by 10. Now, I think I'm going to go up by 10 for every 2 boxes. So basically I'm going up by 5 per box, because this first one, if that's 50, 1950, I'm going to put 60 here. My little marks goes here actually. So 1960 there. And then this would be 1970. And then I go 80, 1980 to 1990. And then look, I can spread across to 2000 right there. And I might put this as 1900s to 2000. My pen's not working very well, but 1900s to 2000, so that when I see this first one, it says 50, I know it's 1950, 1960, 1970, 1980, 1990, and then 2000. Now with the money. Now, I don't have to go up by tens for the money because my smallest Y value is like 0.75 and my biggest Y value is like 5.15. So if I go up by tens, I'm going to literally fill up all this space within the first, section, first little box that's going up by, it's going to be all squished in there. So I'm going to think through how to space out from 0 to 5 about, or 0 to 6. So I might just count up by ones for every 2 boxes. 1, 2, 3, 4, 5, And then because I go at my biggest value is 5.15, it's bigger than 5. So I'm going to leave some room where I can go from above 5 here. So I'm going to go up to 6. Now I'm going to plot my graph. So 1950, I'm at 0.75, which means I probably am at 3/4 of this section. So it's going to be like right here. And this is a scatter plot. Does it have to be exact? I'm not looking for you to be exact. Okay. Well, it would be nice if it was exact, but it's a scatter plot. I'm looking for a general pattern. That is the goal here. 1955. So 1955 is right here and it's 0.75. So that's right here. 1960 is $1. So it's going to be at $1 right there. 1965 is at 1.25. So just a little bit above 1 maybe. And then 1970 is at 1.60. So I'm going to put it a little bit above 1.5 there. And then 1955, 2.10. So right there maybe. Then I have 1980 is 3.10. So going up here. 1985, 3.35. So maybe over here. 1990, 3.8. So maybe over there. 1995, 4.25. So I'm going to go there. And then 2000 is at 5.15. So I'm going to go up here. So see how my plots don't make a complete straight line, but it shows a general pattern. You're going to have a problem like this on your homework where you have to plot the points from a real life example. What I want to see on your homework is that you have a title, you've labeled your X and Y by the units that you're looking at. So if you're looking at height, then you want to label it inches or centimeters. And then you'll need to label the numbers on your graph. Of course, you don't have to put every single number on there, but I need to know what general pattern each box represents. So you could go up by 10s, you could go up by 5s, you could go up by 2s, you could go up by 1s. But you're going to have to decide how you're going to space that all out on your graph. And then of course, plotting the points where it's relatively correct. Please use a ruler on your homework. This kind of graphing is not meant for you to freehand, okay? So when you're drawing the little X and Y axis, draw a ruler, use a ruler, and draw that out and do your best. Try to be as neat as possible. And of course, the reason why I've asked you to get graph paper is so you can use graph paper when you plot your points and do this. So do it on graph paper. And I'm not going to write this out because my pen's not working. So that's all for today. Good job, and I'll see you next time.